Let's study power flow and efficiency of DC machine. First, DC generators. Power flow is very obvious, in fact. First of all, you should draw connection diagram, and then you can draw equivalent circuit, but you can directly estimate where the power is consumed. For example, here is a power converted on this device. That is armature, making energy conversion. Here is armature resistance, so armature resistance causes copper loss in armature, a kind of loss you see. And here is another loss, that is field winding resistance. Let me say shunt field. In fact, it is here's shunt field coil, R field shunt instead of this guy. So there is a copper loss in field circuitry, which is IF squared times RF shunt. That is copper loss in shunt field coil. And here is a rheostat to control field circuit current. So there is a loss, copper loss again, or joule loss on resistance. Here it is field controller. IF squared times RF controller, field controller rheostat. It is not necessary, but it is we generally use such a simple control element here. And there is another loss, which is serial winding loss. Here it would be, if this is a compound machine, for example, here is one shunt field coil, here is a serial field coil. So copper loss in serial field coil is equal to, let me say, field serial. So those are field shunt, field serial squared times R field serial. This guy, R field serial. In fact, you see this current is equal to load current in generator. You can also write load current squared. Those are losses. 1, 2, 3, and 4. Here are 4 lossy elements we have already written down. So, input power, which is mechanical power or shaft power. First, there is a mechanical loss in terms of friction and windage, but you cannot see in equivalent circuit. Those are rotational losses or mechanical losses. Then rest of the power will be converted into electric power across this device, armature. And then here are 3 losses we have mentioned here. In fact, field controller rheostat is not given here. It would be, but it is not necessary every time. If you add a resistance, you can add here field controller losses, but it is not general. Rest of the power will be output electrical power. So, ladies and gentlemen, everybody knows efficiency is equal to output power, input power. Here is output electrical power, or simply we use P. Input is equal to output plus losses. Here you see possible 4 losses, all must be included here. So that is the efficiency. Let's discuss motor operation. In motor operation, similarly, here's a loss, here's another loss, here is a native loss in compound machine. As you see, that's a compound machine in general case, having a shunt field and serial field coils. Here's extra loss in field controller. In fact, ladies and gentlemen, here would be another element, would be here or somewhere here. That is, let me say RX or starter rheostat. There would be a rheostat to control startup current. Again, it would be a lossy element. Now, as you see, in motors, we apply electric power, which is input power, and we will have mechanical output. First, you apply electric power here. Let me change color. We apply electric power here. And here's serial winding losses. Here it is. Copper loss in serial field coil. Then here would be shunt field losses. Here it is. Copper loss in shunt field. And then here would be some armature losses. Copper loss in armature. Then the power will be converted into mechanical power. That is the converted power across these elements, on these elements. And now applied electric power will be converted into mechanical power. It is fresh right now. Here are some mechanical losses. Sometimes we say rotational losses in terms of windage and friction. So when after these losses, rest of the power will be delivered on shaft. That is the output. Ladies and gentlemen, as you know from the mid school, efficiency is always output power over input power. Here is the mechanical output. Here is the input power. Output can be written as input minus losses, or sometimes we write output over output plus losses. All those are equivalent and correct, and you can calculate efficiency easily. That is the summary of efficiency and power flow. Don't forget, first draw connection diagram and then follow the losses. Mark the losses, draw a balance diagram, power balance. That is the power balance. And then calculate individual elements and substitute in the efficiency equation.